Hello friends, my name is Rajat and today we are back with yet another video on a Leetcode problem, minimum length of string after operations. In this problem we are given a string s and we can perform the following operations any number of times. We need to choose an index I in the string such that there is at least one character to the left of index I that is equal to s of I, and at least one character to the right that is also equal to s of I. We need to delete both the closest character to the left and to the right of this index, and at the end we need to return the minimum length of the string s that we can achieve. There are certain examples given with the problem, and we have constraints with the problem that the length of the string can lie between 1 to 2 into 10 raised to power 5. One more constraint which is very helpful in this particular problem is the string consists of only lowercase English letters. We'll first understand what the problem is all about and how we can solve it. So this was the first input that is given to us, and we know that the output given to us in this particular case was 5. Now, how did we achieve this particular output? When we take this particular string, we see that we have to find out any index, and then we need to find out the closest left and right indexes which has the same character. Once we have found these particular characters, we need to simply delete both the characters. Remember that we are not deleting the chosen index, we are just deleting the characters on the left and right of that particular index. Now we again select a character b, and the closest left and right index which has the same character are these two. We simply delete these two as well. Now remains the string which has length 5. Since we cannot perform any operation, this is the output that we get. Now the question that arises over here is, what would have happened if we have chosen the other b? This was a string before. What if we have chosen the second last b that we have? In this case, the closest left and right changes, and we again get a different string, but the length of the string is still 5. So if we compare the two strings that we get at the end by performing different operation on the previous string, we see that the end string has length 5, and that is what matters in this particular problem. The relative position of each character in the string is of no significance in the result that we need in this particular question. So if we head back to the input, we have this input wherein there are multiple characters involved. So for simplicity purpose, let's remove all the characters and just leave only one character. If the input was only a, so the input string is a, and we select this particular input string, we need to find out whether there lies a character to the left and right of this particular index which is same as a, but we do not find anything. Since there are no characters to the left or the right of this string, the output to this particular input string will be 1, since the final string will have one character, or the string will be of length 1. We'll put that into a table. Now let's introduce one more character a into this particular input. Again, in this particular case, we select one of the two indexes and try to find out whether there lies a left and right index which has the same character. We find out that left index exists, but the right index does not. And if we swap the indexes, we see that the right index exists, but the left does not exist. So the final string in this case will be of length 2, and we'll put the same in the input output table that we have. We again introduce one more character into the input. We try to find out an index wherein it has a left and right indexes with the same character. We find out this. The operation that we need to perform is deleting both the indexes of left and right, keeping the current index. We get the final string of length 1. This means for length 3 of the same character, the output would be 1. We again introduce one more character into this input. We have 4 A's. We select any index closest left and right. We delete the two. the string remains is of length 2, we put that into the table. Do you see a pattern over here? Try to come up with the pattern that we are seeing over here, but for more clarity, let's take an input big enough for you to say it. We have 10 A's in a row as the input string. Now, what will be the flow of this particular string when we perform the operations given to us in the problem? It will look like this. We select a particular index, we select the closest left and right, we delete the left and right, and we do that 4 times, and at the end the string that remains is of length 2. We put that into a table as well. So when A is 10 times in the string, the output is 2. What kind of pattern do we see here? We see that when A was present only once, the output was 1. At the end, only one A will remain. If A is 2, then the output will be 2, since no operation can be performed on 2 A's. The real operations starts from when there are 3 A's, or the count of the character in the particular string is 3 or greater than 3. When it is 3, you select any particular index, you delete the left and right, and only 1 remains. When there are 4 character count, then also we can perform the operation only once, and the remaining character count will be 2. We see that for odd count, the remaining character would be 1, and for the even count, it will be 2. Now let's apply this particular logic into the initial input that was given to us. The initial input has 3 characters A, B and C. Let's create a table where we have characters, the count, and the final remaining character count that we will have after the operations. So the count of each character is 3, 4, 2. There are 3 A's, 4 B's and 2 C's. We know that for odd count, remaining character would be 1. For even, it will be 2. For A, since it is odd, it will be 1. For B, since it is even, it will be 2. And for C, since it is even, it will still be 2. So the count would be 1, 2, 2 respectively. If we add the 3 final counts for each of these characters, we'll get the output as 5, which is the answer that we are looking for. Now I will recommend you to code this particular approach, and then you can continue forward to see how we are solving it. Now it's time to code this particular approach. For simplicity, we'll convert this string into a character array. We needed a count for each of these characters, since we know that the string can contain only lowercase English characters. We would use a 26 length count array. We'll iterate over this string. We'll increment the count array. Now this can be converted into a for each loop. Let's do that. Once we have the count, we need a result variable for every count. So we know that if the count is even, we need to increase the result by 2, and if it is odd, we need to increment it by 1, and at the end we need to simply return the result. Now there is a problem with this particular code, since the count for the characters which are not present in the string will be 0, and the condition for them, this would be true, and result will be incremented with 2. So we need to bypass that. We need to include it by saying if the count is 0, we don't do anything and we continue. Let's write this code in more concise way using ternary operators. If the count is greater than 0, only then we can perform the operations. The result is incremented based on 2, otherwise 1. This completes the coding part. Now let's run it for the sample test cases. So it ran successfully. Let's submit it. So it got submitted successfully. The time complexity of this particular approach is of n, since we are iterating over the string once. The space complexity for this code is of n, since we are using character array to hold the characters. We can use as.caret as well and make the space complexity to be constant. That's all for today's video. I hope you like this video. Do let us know your thoughts, comments and queries in the comment section below. Thanks for watching. See you in the next one.